Hi everyone, this is Chicho. Welcome to my channel and welcome to another mathematics related video. And what we're going to do in this video, we're going to explore the data we looked at in a previous video we loaded up, where we looked at the data we have available regarding COVID-19, the Wuhan coronavirus, and what we ended up doing in that previous video, which the link will be provided in the description of this video, and I'll provide a link to our Patreon page where you can take a look at this table and the graphs we looked at in that video, right? But basically what we did in that video was we looked at each one of these columns and we graphed them, right? Because that's one thing you do in mathematics when you're looking at data, when you're trying to crunch data, trying to get a feel for what data is telling you. You create your table, do whatever number crunching you need to do, preliminary number crunching anyway. That's what we're doing right now as the data is becoming more available, right? And then you create visuals for your data. You graph them and take a look at them. And a graph can tell you a lot in one shot than what you can get out of a table. The table is brilliant, okay, don't get me wrong, the table's brilliant, but a visual, a graphical visual provides a lot of information, gives you a great feel for what the data's telling you, right? And the links to the video and the Patreon page where we uploaded these pics, the table and the 11 graphs, there's 11 graphs we looked at, I believe, right, will be available in the description of this video. And for those of you that are supporting this work through Patreon, thank you very much for supporting this work through Patreon, because it's because of your support where that we're able to do this, right? That we have a page there where we can share information, share content, and explore mathematics and other things as well. And for those of you who are thinking about, and I've had some questions come my way regarding how the best way is to support this work, definitely by sharing, liking, commenting, interacting, coming to our live streams, right? But if you do have the funds, through Patreon is a fantastic way to support this work. It'll allow me to acquire more hardware, more software, more content to be able to create all this, all these videos and all of this content, right? Materials anyway I can acquire. Okay, aside from that, let's explore this data. Okay, now I uploaded this video, and what we did with this data set, we looked at the data from January 20th until February 29th. Okay, now today is March 3rd, so I uploaded this video. We did the live stream on, I believe it was March 1st, okay? And then March 2nd, I uploaded the video, just a segment of it, right? And the live stream, most likely by the time you watch this video, you're watching this right now, the live stream will be available as well, right? So there's two videos that we got out. One of them was basically going through the data, through the graph, that we pulled out of the live stream that we did, right? So if you just want to explore the data, you can take a look at about a 30-minute video. If you want to see where the discussion took us regarding the data set, it's the live stream you want to look at, right? And the data that we looked at was from January 20th, 2020 until February 29th, 2020, today being March 3rd. Now, when I uploaded this video yesterday, there was a comment that was posted, which was a fantastic comment, right? It was a very legitimate question. And the question was this, because when we looked at the data, we found discrepancies in the data, something that, you know, there was divergence, right? And the divergence was happening here. It was happening between the number of confirmed cases, not the number, but the percent growth per day of confirmed cases in China versus the percent growth per day of new cases being reported outside of China. Because the number of confirmed cases inside China as of February 15th was only growing by 3 to 1 to 0% per day, while the number of confirmed cases outside of China for the same period from February 15th all the way to February 29th was growing at the lowest from 9 to the highest at 30%, between 9 and 30%, right? So the number of confirmed cases outside of China per day was from February 15th was 15, 14%, 15, 12, 10, 9, and then it started kicking up into the high teens and into the 20s, peaking at 30, and now stabilizing around the mid 20s. While the number of, or the percent growth per day inside China is 310%, right? So that's a serious discrepancy between these two data sets. Okay, take that whichever way you want. What's happening? We talked about this during the live stream, and I really don't want to explore why this is the case. I just want to look at the numbers and answer the question that was asked for that video we uploaded. And the question was this: what would the total number of cases be if China's growth rate was the same as the numbers outside of China, right? Fantastic question, and it allows us to explore this data set a little bit further, right? Because that is exactly what we're going to do. We're going to continue building this data set and most likely doing a live stream and video every month as an update, just to see what the data is telling us and where it's taking us, right? And what we will do, and what we are doing right now, is linking this up with ASMR mathematics, right? Functions. Specifically right now, what we're going to take a look at is exponential growth, right? Which is something we talked about. This whole thing started off during a math live stream we did when we started talking about exponential growth, and that was like a month or so ago, right? But we only had a little bit of data regarding COVID-19 coronavirus, and we talked about what the exponential growth might look like, right? So we're going to definitely link this up with the content we're creating for mathematics regarding functions, specifically exponential growth. And at some point, once we acquire enough data where we can do some hardcore analysis on that data, what we're going to do is link this stuff up with a module that we're going to create regarding probability and statistics, because I think it'll be well worth exploring this this data set, right? It's a fantastic opportunity to learn mathematics, right? And make it centered around something that's happening in the real world, right? Math in real life, right? As it relates to the content that we're creating on this channel, may it be related to ASMR mathematics, language of mathematics, and all the content we're creating regarding math in real life, right? Just to give you guys a heads up, this isn't going to stop here. We're going to continue to grow this, right? But what I'd like to do right now is do the little bit of analysis we can right now based on the little bit about the data that we have. And the analysis we want to do right now is answer this question: what would the numbers be if the growth in China was the same as the growth that was happening, that is, that we're seeing outside of China? Okay, so let's put the numbers up here and we'll see where it takes us. Okay, so again, you can find the link in the description of this video to this table that you can find on our Patreon page, and you might want to take a look at that because these are way too small numbers, right? Well, actually the camera is doing a good job focusing on them. And what we're going to do is we're going to look at the numbers from February 15, okay, all the way to 29. That's what we're going to look at. Okay, and there was a, you know, if you go to February 13th, you'll see a gigantic jump up in the number of confirmed cases per day being reported in China, and that was because China changed their criteria of the way they were either measuring and reporting them or whatnot, right? We're not going to explore that right now. We talked about it during a live stream. We're more concerned about answering the question: what would the numbers look like if the number of confirmed cases were growing at the same rate inside China as they are outside China, all right? So let's put the dates here. Okay, we're talking February, so the date is February 15th, okay? And the way we made the charts, we made it based on day count, right? We start collecting data from January 20th, so we call that day one, and this data set is taking us all the way to February 29th, so that's day 41, okay? And that's the x-axis that we have. So I'm going to refer to the days that we started counting. So day is, we're going from day 27, right? And the number of confirmed cases we have in China on day 27, so let's put China here, is 68,300. So 68300. Okay. And the number of confirmed cases we had outside of China, and let's call that other, was 685, right? 85. Now, we take this down, we're going all the way to February 29th, leap year. Cool. All right. And that's day 41. And the official number of confirmed cases we had being reported from China was 79,784. So 79,784. And the number of confirmed cases we were getting outside of China was 6,800. All right. So 6,800. Okay. Huge jump, not as much, right? Because from here, right, in these 14 days, if we count it, day 41 minus day 27, right? That's 14 days of growth, right? If you do 14 days of growth, let's put the numbers here. Let me grab this. Let me grab we'll grab a purple pen, okay? So let's do this. Here, we'll grab a little calculator too. And what we're gonna do, we'll figure out what the multiple is from here to here, okay? If you do the multiple, and we're going to do this with exponentials, we're not going to do them with multiples, okay? So if you want to find out what the multiple is, just take this divided by that. 6,800 divided by 685, you get 9.9, a multiple of 9.9, okay? So from here to here, this is a multiple of, let's write this down, times 9.9. Okay, if you want to know what the percent growth is, just go this minus this and divide the whole thing by this, right? I believe so anyway. So we're going to go 6800 minus 685 divided by 685. You get 893% growth, right? So this is 893% growth from here to here. Okay. We're going to do some crunching numbers here, right? It's going to be a little bit messy, but as long as you're following it verbally, you should know what the numbers represent, right? Let's do the same thing here. If you want to get the multiple, this was 9.9. Let me make the decimal better so you see it. Okay. If we're going to do the multiple here, you're just going to go 79784 divided by 68300. You get 1.17 multiple. So this is 1.17 multiple going from there to there. Okay. And if you want to do the percent, you go this minus this divided by that, right? So you're going to go 79784 minus 68300, boop, and you're going to divide by 68300, and you get 17% growth, right? So from here to here, we get the 17% growth, right? Huge difference. 17% from here to here, 893% from there to there, right? Now, there's a whole bunch of reasons why this might be happening, right? And we talked a little bit about them during the live stream. Now, why is this discrepancy here? Because the percent growth per day inside of China the based on the numbers being reported was anywhere between 2 to 3%, and the percent growth per day outside of China was going between 15 in the teens and then dropped down to around 9%. It kicked up to the mid 20s all the way up to 30. Now what I ended up doing was, just to simplify our calculations, in the percent growth per day column, which is column number 1, 2, 3, 4, 5, 6, 7, 8, in the 8th column in this table, if you take the average from February 15th all the way to February 29th, percent growth per day was averaging out to be around 18% growth per day. So we're going to assume the percent growth was averaging around 18% per day. Okay, just to simplify our calculations. Now, if we're going to do that, right, let's see what the number would be if we had 685 confirmed cases outside of China, growing 18% per day for the 14 days we had, from day 27 all the way to day 41, right? And the way we do that calculation to find the number that we'll see, we want to see if it confirms with this number, right? Now, it's not going to be exact. Keep this in mind, because if you're growing 18% per day, it's a smooth thing happening, right? If you're fluctuating between 9 to 30%, average, it wasn't fluctuating as much, 9 to 30, 9 to 30. It was around the teens in the beginning period here, in the beginning week or so, and then in the second week it was kicking up into the mid 20s, right? But we're smoothing it out. We're going to take the average, okay? But it makes a difference if you're starting off with a smaller percent going up to a bigger percent, or a bigger percent, smaller percent, right? Because the initial kick for this, if you're growing exponentially, it really depends on where you start. If you start up a little bit higher, the number is going to be much higher if you're doing exponential growth, right? We're going to explore this further when we look at more data and we start doing a little bit more mathematics related to exponential functions or whatnot, right? But for now, let's figure out what 685 number of confirmed cases outside China, what the number would be on February 29th, on day 41, if the average growth was 18% per day. Let's see if it comes out to around this number, right? And the way you do this calculation is the following. You're going to take 685, right? To go to the next day, you're going to multiply it by 1.18, because 18% is your converted to a decimal is 0.18, right? And you're going to add 100% to it, which is a 1, because you need your original number as well. So the way that works is you just have to multiply 685 times 1, representing the 685. You're going to multiply 685 by 1.18. The 1 is this guy, and the 0.18 is the growth, right? So 685, let's do this here. 685 times 1.18. Let's see what the number would be on day 28 if it's growing at 18%, right? On February 15th, day 27, if we go to February 16th, day 28, at 18% growth, let's crunch that number, see if it's, see what we end up getting, right? So we're going to go 685 times 1.18, which is 808 confirmed cases, right? 808 confirmed cases. Now our table tells us that on that day we were at 780 confirmed cases, because the growth per day from there to there was not 18%, but it was 14%. Okay, so do you see where I'm going with this? It's going to vary a little bit, but it should stay true to the flow of the data, right? Now, what if we wanted to find out? So this would be on February 26, right? So this is Feb 26, day number 28, day 28. So what if we wanted to find out what the number would be on February, no, not 26th, sorry, February 16th, right? That's what happens when you have little brain farts, right? What if you want to find out what February 17th would be? What day, what numbers would be for day 29? All you do, you take this number and multiply by 1.18 again. Now keep in mind, this number is really this number, right? So what you can do is say, oh, just take this number, this, and multiply by 1.18, right? So you could go 685 times 1.18, which is really this guy, right? Take this, that's that guy, because that's that guy, times 1.18. Let's see what we end up getting there. So all you're really doing is just multiplying 808, let's do it this way, 808 times 1.18, which is 954, right? So you get 954 confirmed cases for February 17th, day 29, right? Well, if we continue to do this all the way to February 29th, all we're doing is we're taking this number and multiplying by 1.18 again, right? So now, 2 more days in, we got 1.18 times 1.18 times 1.18. Well, that's just exponents, right? So to figure out what the number should be here if we have 18% growth per day, all you got to do is take 685 times 1.18 to the number of days that we have. And the number of days that we have is just 41 minus 27, which should be 14, right? 41 minus 27, which is 14. So what we're doing, we're multiplying this by itself 14 times. So it's going to be to the power of 14. Okay, let's punch this in and see if it comes close to that, right? So we're going to go, I'm going to go 1.18 to the power of 14 first, right? 1.18 to the power of 14, and that gives me 10.15 rounding, right? And then I'm going to multiply it by 685. You get 6,950. Okay, so let's put this in purple. So if you run this number, actually let's put this one black, 6,950. So I'm going to put that here, 6,950 for February 29th, day 41, right? Sort of getting off on the edge of the part we have here, but we can put that number here. That becomes 6950, right? Based on the way averaging out the percent growth per day for the number of cases we see outside of China, it's close enough, 150 difference, right? Not bad. So we can do the same thing for this. Now we could do it with the multiple, right? We could just take 68300 and multiply by 9.9 because that's the multiple we had here and get a number. That's an easy way of doing it, right? And that's just multiplication. It's not about exponential, right? It's not about powers, right? Which is the direction I'm planning. I want to take this in, right? You can also multiply by the percent increase, which would be multiply this by 8.93 to see what you end up getting. Okay, but let's do it this way, because if we do it exponentially, then all we've got to do is take this and put it here and multiply it by this, right? So let's see, if we do it here, the number is not going to show up on the screen, so I'm going to move over a little bit. So I'm going to do the same thing here. I'm going to take, let's see, is the number going to show? Can I write this far? No, I can't write that far. Crunching the numbers. So let's put it here, 68,300 times 1.18 to the power of 14. That's exactly the same as this. All we're doing, we're changing our starting number, right? That's all. So if we do that, what do we end up getting? What do we end up getting? What do we end up getting? We're going to get 1.18 to the power of 14, which is again 10.15 times 68300. We get a big number, right? We get 693,057. Let's see how far. Let's write this down. 693,057. Yeah, you can see that. Awesome. And let's put the number there so it stands out, right? Let's put our calculator down here. And this would be 693,057. What does this number mean? It means if the growth per day inside China was consistent with the growth per day of confirmed cases that we're seeing outside of China, averaging out to be 18% per day, then the number of cases we would have had on February 29th is not 79,784, but it would be 693,057. So it wouldn't be 80,000 if we're rounding, it would be 700,000, right? Now, keep this in mind. This is just playing with the data, just crunching the data, trying to get a feel for the data, right? We're entertaining ideas. We don't know why that discrepancy exists between the numbers being reported from inside of China and the numbers being reported outside of China. Maybe the virus has burned itself out. Maybe it's mutated. Maybe they were able to contain it and treat everybody and everybody's doing well, right? Or majority of people doing well, because unfortunately there are deaths associated with this, right? So we don't want to throw, go beyond what the numbers are saying, right? We don't want to take these as absolutes. We just want to entertain the idea. We want to take a look at the limits, look at the extremes, do a comparison between one situation, another situation that we're seeing, right? Based on the same virus. Maybe this thing started off early and China was growing exponentially super fast right away, right? And now that it's come out outside of China, maybe that's what we're seeing happen outside of China, and it's going to slowly die off, and hopefully we're going to get, not even growth, but hopefully it comes down to what is being reported in China, which is 0% growth per day, basically, or less than 1% growth per day, instead of 18 on average growth per day. Teens. We're sitting into the mid-20s right now. Growth per day outside of China, right? We'll see how it plays out. Okay, I thought it was a fantastic question. It's something we'll explore further. We're definitely going to do a lot more analysis on the data, time permitting, and as we acquire more data. And we're definitely going to link this stuff up with ASMR mathematics, language of mathematics, math in real life, and definitely use this data when we get into creating a module for probability and statistics, right? But I thought it was a good idea to explore this a little bit further because we have the data available to us, right? And it is important. This is math in the real world. This is something that shows us the true power of mathematics, right? Because mathematics is not emotional. Mathematics doesn't care about anything else other than the numbers. And what you can do is tabulate numbers, graph numbers, and explore the data set just to try to see where it might be taking you, where there may be flaws in the data set, discrepancies in the data set, right? Deviations in the data set. Okay, and this is definitely one place we're seeing a deviation, and sooner rather than later we'll find out what the situation really is, right? And we'll keep a close eye on the data and see where it takes us. Okay, aside from that, thanks for being here. Thank you for the support, thank you for the love, thank you for the comments, Thank you for the interaction. Thank you for being on the live streams if you are coming to Twitch. And thank you for the support if you're supporting this work through Patreon, direct donations, through Subscribe. We just recently started it, but through Patreon and whatnot. It's through your support that we're able to do this work. And if you do like what we're doing here, you do appreciate this work, and or you are finding it of use, consider supporting this work through Patreon. With your help, with your support, we can expand this this project and start producing content at a maybe more regular pace and more consistent pace, and start linking up some of the mathematics that we've already laid out and putting everything together, and start releasing some of the modules we plan on releasing. Okay, I hope you find this useful. I'll see you guys in the next video. Bye for now.